You've seen the headlines, right? Bitcoin soaring, digital art selling for absolutely insane amounts of money. But the real story here isn't just about the cash or the pixelated apes. It's about the revolutionary tech that's making it all happen, Ethereum. So let's pull back the curtain and really deconstruct what's going on under the hood.
It all boils down to a pretty simple but kind of profound question. I mean, think about it. In a world where you can copy and paste literally anything with a single click, how can any digital file be truly unique? How do you own a JPEG the same way you own a physical painting? Well, the answer lies in one powerful idea.
And that idea is fungibility. Now, it sounds like a super technical, complicated word, but I promise it's something you deal with every single day. It's just the idea that some things can be swapped out for one another without any loss of value. One unit is just as good as any other.
Okay, check this out. It's actually super clear when you see it laid out like this. A $100 bill? Totally fungible. You don't care which $100 bill you have, you just care that it's worth $100. Same goes for a barrel of oil or even one Bitcoin. But the Mona Lisa? Nope, that's one of a kind. It is non-fungible. Your house with its specific address or that concert ticket for seat J12. They're unique. And that's exactly what a non-fungible token, an NFT, is. It's a unique, provable, one-of-a-kind digital thing. So what's the technology that makes this all possible?
That brings us to the engine room. You see, while Bitcoin was the pioneer, it gave us this incredible idea of decentralized digital money. Ethereum came along and basically took that core concept and put it on steroids. It's really the difference between a tool that does one job and a tool that can do every job.
So, the absolute key difference is in their programming languages. Bitcoin uses something called script, and it's intentionally very limited. You can think of it like a super secure but really basic calculator. It's built to do one thing and do it extremely well: process transactions. Ethereum, on the other hand, uses Solidity. It's what we call Turing complete, which is just a fancy way of saying it can run pretty much any program you can dream up. This is what transforms Ethereum from just a payment network into a global decentralized computer, a computer capable of running all these complex applications that manage NFTs.
And this quote just nails it, doesn't it? Blockchains evolved from being just digital cash systems to becoming the foundation for a whole new kind of internet. But that raises a huge question. How in the world do you run a global computer that has no one person in charge? How does everybody agree on what's what?
Well, it turns out you need two fundamental ingredients for this recipe. You need a way for everyone to agree on what's true on the network, we call that consensus, and you need a way to pay for the work being done on the network. We call that gas.
Consensus is really the magic that makes this whole decentralized dream work. It's just a set of rules that lets thousands and thousands of computers all over the planet agree on the facts, like which transactions are valid and who owns what, all without needing a central bank or some big server to be the boss.
Now, there are a couple of main ways to get this agreement. Bitcoin uses what's called proof of work. This is where miners use massive amounts of computing power to compete to solve these really hard puzzles. It works, but it uses a ton of energy. Ethereum, though, made this famous switch to proof of stake. With this system, validators are chosen to create new blocks based on how much crypto they've staked, or basically locked up as collateral. It secures the whole network using economic incentives instead of just raw processing power, which is an absolute game changer for energy use.
Okay, so if Ethereum is this giant global computer, then every single thing you do on it, whether it's sending some crypto, creating an NFT, or using an app, it all takes computational power, and that power isn't free. That's where gas comes in. It is quite literally the fuel that pays for your transaction to get processed and added to the blockchain.
And the cost of that fuel is your gas fee. Now, you can see the formula here, but don't get hung up on the math. What you really need to know is that your total fee depends on how complex your transaction is, that's the units used, multiplied by a network base fee plus an optional priority fee, which is basically like a tip you can give to a validator to get your transaction done faster. But here's the catch. When the network gets really busy, that base fee can absolutely skyrocket. That can make simple transactions pretty expensive, which can be a real problem for some of the amazing applications we're about to talk about.
All right, so we've got this powerful, decentralized computer that can create unique digital things. And yeah, digital art gets all the hype, but the real long-term potential of NFTs is in their utility, and it goes so far beyond just being collectibles. I mean, just look at this list. We are talking about fundamentally transforming entire industries. Imagine owning just a small piece of a skyscraper, or actually truly owning the items in your favorite video game, or having a digital passport that you and only you have complete control over. This isn't science fiction. This stuff is being built as we speak.
So let's take real estate, for example. By turning a property into a collection of NFTs, you can create what's called fractional ownership. So instead of needing millions of dollars to buy an apartment building, you could just buy one NFT that represents a tiny share of it. You'd earn a piece of the rental income and benefit if the property goes up in value. It completely opens up access to a market that's been historically closed off to most people.
And what about gaming? Oh man, this is a revolution for players. For decades, you've spent your time and your money on in-game items, skins, weapons, you name it, that you never actually owned. They always belong to the game company. NFTs flip that script completely. The legendary sword, or the rare skin you get, is yours. You can sell it, trade it, maybe even use it in a totally different game one day. This is how you build real, functioning economies inside of virtual worlds.
But maybe the most powerful use case of all is identity. Just imagine your university degree, your driver's license, even your medical records, all existing as NFTs that you and only you are in control of. You grant access to people when they need it, and you can revoke that access instantly. It's a fundamental power shift, taking ownership of our data away from big corporations and giving it back to us, the individual.
But, as you know, with great power comes some pretty significant risk. This technology is still the Wild West in a lot of ways, and wherever there's this much money and innovation, you can bet there are people trying to exploit it. So, what are the biggest dangers out there? Well, first up, you've got flaws in the smart contract code itself. These can be simple bugs, or they can be devastating exploits like reentrancy attacks. That's a nasty one where an attacker can just keep withdrawing funds over and over before the contract realizes what's happening. Then you've got issues with the marketplaces where people trade. And of course, you've still got the classic cybersecurity scams, like phishing attacks, trying to trick you into signing a transaction that drains your entire wallet.
And listen, this stuff isn't just theoretical. This actually happened. A bug in the original code for CryptoPunks, one of the most famous NFT projects ever, did exactly this. An attacker found a loophole and was able to basically get a free punk by exploiting the logic in the code. The stakes are incredibly high.
So how do you protect yourself? Okay, first, if you're a creator, you have to get your smart contracts audited by professionals before you launch anything. For everyone else, try to stick to truly decentralized platforms where you are the only one who controls your private keys. And most important of all, be paranoid. Triple check every single transaction you're about to sign. If a request looks even a tiny bit sketchy, just reject it. It's not worth the risk.
So, this is where we land. We have this incredible technology that can create true, verifiable digital uniqueness. It can power a whole new generation of the internet and completely redefine what ownership means. The potential is just massive, but the pitfalls, the risks, they're just as real and just as deep. And that leaves us all with a really critical question to think about. Is this powerful, risky, and revolutionary innovation actually worth the leap?